Hey students, this is the second time I did this video. You didn't see the first time, but I am just going to make this quick. So today's lesson is going to be on distinguishing volume and surface area. We're going to look at two of those things and combine them in a real life problem, one problem we saw before. And then after that, please do the learning activity. That'll be the rest of the lessons for this week. We got one more next week, and yeah, that'll be it. And then we got a PC, right? But let's get started. Today you should be able to decide You can decide whether you need to find the surface area or volume when solving a real world situation. All right, so let's talk about chocolates again. Remember last time, I think maybe a couple lessons back, we talked about some chocolates in a box and trying to find the surface area of it or the area of volume or something on the prism, right? But let's revisit that. And again, here we have looks like we did do the volume. So here we have a box and we're trying to create it, the chocolate box. It has a depth of 2 inches, meaning that, right, we have any old box. Let me see if I can find one here. I don't have a box, but I have my phone, right? Pretend this is a box. And we have here the depth area, right? This is going to be a depth, right? We have the faces. Technically, this is, if it was more straight edged, it would be a prism. But for our heart shape box, we're going to try and make it out of cardboard, but we need to understand that this side of it, right, that side of it, that is going to be 2 inches, right? That's going to be the height of this box. Notice how this is a prism because we have here the front, and then we got a back, right? This is the front and the back. They're going to be the exact same shape of a heart, and we could use that to find our volume and surface area. Before we get into trying to find how much cardboard is needed to create the box, let's first think of what does that mean? We need surface area. Okay, we want how much of box we need. That would be surface area. Some extra measurements that I'm going to add on is that with the diagonals that you see in that box with the heart shape, I'm going to put those in for you. That's some other math that you'll learn in 8th grade, but I'll give that to you as 6.4 for the diagonals in the bottom, and on top is 2.2, all right? But anyway, so we're trying to find surface area. Let's go ahead and put that together. So remember, surface area is when you add up all the faces. Surface area is when you add up all the faces, right? Well, in this situation, for our cardboard box, we're going to have 2 different faces or 3 faces, right? We have the 2 hearts of the front and the back. So this one could be the front. This one could be the back. So we need to add those. And we also have these sides over here, right? We have those sides. I'm going to tell you straight up, let's go ahead and assume that if I unraveled the border or the thing that's holding up the box, right? I'm unraveling that border. I technically have this long strip of rectangle where we have that net, right? That's gonna be our net. Okay. I'll put it up here. This is our net. So now I got the 3 parts. I have the 2 front and back of the prism and then my net, and I can add all those up to get my surface area. Remember back then, we learned that the surface area or base of this heart, we were able to cut it up into different pieces, right? And then solve the areas of all that. Instead of just doing that, let me go ahead and put those answers in. I believe it was 40 inches squared last time we did this. Okay, so this is 40 inches squared for the surface area or the face of the front and back of those heart boxes. So now the thing I want you to think about is, well, what's going to be the surface area of the net or the strip rectangle that I just stretched out together? Okay. Well, my length for sure is going to be 2 because in the example before, you said the box is 2 inches, right? So that has to be 2. Let me move some of this. Okay. So that has to be 2. But when you think about it, this base of it, this width of it, it's going to be all of these numbers added together. It's going to be 64, 6.4, 2.2. Technically, this is 2, right? So what we're doing is we're taking the perimeter. We're going to get all the perimeter, add them all up, and we should be able to find the length of that strip. So I'm going to take all these numbers that I'm highlighting. All right, I'm going to add those all up. Let me get my calculator out. So we get 2.2. There's 4 of them. 2 times 2. All right. So I add those all up. I get a total of 25.6. Now remember, I need the surface area of that. I need the surface of that net. I need to times those two dimensions together. So 25.6 times 2, that gives me 51.2. Okay, so when I'm adding 40 plus 40 plus this over here, which we found was 51.2 inches squared. You add those all up, what do you get? Well, you should get 131.2 inches squared as your surface area. All right, so that is going to be the surface area of that box. Let's go ahead and do a harder problem. We have a wheelbarrow of concrete. What's going on with this wheelbarrow? Let me see if I can read the situation. Let's see. So let's say we have this wheelbarrow picture over here, and we're trying to get that base of it, that red part that you see. It's being used to carry wet concrete. We're going to find its dimensions. The first thing we're going to do is we're going to try to find the volume of concrete, so how much is getting filled into this wheelbarrow, and then we'll try to find the surface area of it, all right? And I'll read you that situation in a bit. All right, so let's find the volume. Remember finding volume, sorry, I'm getting antsy. Remember finding volume, that is equal to the base area of the prism times the height. So you need to ask yourself, well, what is going to be my base area? What's going to be my face? Looking at it, it's going to look like it's going to be this piece right here, or it's already given right over there, right? So this right here is going to help me find the area, the base area. Now you need to figure out the height. So with prisms, right, the height is always going to be in between of the bottom and the top face of the prism, right? In this case, it's going to be the front and the back. So I can say my height is going to be 70. So I'm going to say my height is 70 centimeters. The main reason is because we have the front right here, and you have that back piece right there, right? Squished in, that makes that height, that length, if I put it upwards, right? Right now it's kind of facing like this, but if I stood it up, you'll see that the height is 70. All right, so let me go ahead and take this piece, and we're gonna use that to find the area. So I can break this up. Right now I don't know how to find the area of that. That's technically a trapezoid. But I'm going to go ahead and cut this into 2 triangles and 1 rectangle. So if I was to get those pieces, here's my first triangle, right? And then you have my rectangle, and then you have your other triangle. I need to add those together to get my base area. All right, let's talk about the dimensions here. Well, the rectangle, that's easy. That's a 40 by 66. Looking at the little triangle on the right of that, it's a 34 by 66 as well, right? Because the vertical lines match each other. And then I need to find the other one. The height is going to be 66, but my kind of that top part, or that, I guess you can call it the width of it, of that triangle. Okay, what I'm talking about is up here. That is going to be, technically it's going to be 106 minus 40. Okay, so 106 minus 40, let me just do this math on the side. 106, so this piece right here is equal to 106 minus 40. That should also be 66. Okay, let me do that in black. 66. I'm just double checking because last time I messed up a lot. But that looks good to me. So if I was to do the math of this, it's 1/2 times 66 times 66, width times length. Next one is 40 times 66. And then you have 1/2 times 34 times 66. Okay, you need to use a calculator, put all these together. Let me do that right quick. And this isn't going to give us our final answer. It's just building on to that final answer, right? So we have here, I'll just do this in red, 2178 plus 2640 plus 1122. Okay, so the base area, I'm going to add all those up, is 5940. Whew, I'm nervous because I don't know if I got their answer, but we'll try this. 5940 centimeters squared. So remember, to find the volume, my volume, well, that's equal to the base that I found, 5940, times my height, which I said is 70. And what does that give me? Should be a big number. So we do 5940 times 70. That gives me 415,800 centimeters cubed. All right, that is my answer. Okay, go ahead and pause if you're stuck. Remember, you can go back and put all those pieces together. But again, I broke it into 2 parts, found my height, and then with my base area, I broke it into 3 parts in there, added them up, times, and that gave me my volume. I realized I just spelled volume wrong. I spelled it as volume. All right, we're almost done. So if I found that base area, let's go ahead and find the surface area. Remember, this is a wheelbarrow. With a wheelbarrow, there is no top side, right? All we have in this wheelbarrow is going to be this kind of figure going on here, right? And what we're trying to find now is the surface area. And you can find the surface area by adding all the faces, right? You take the face, the area of each face, add them all together. Or remember, to find the surface area, so the surface area I'll call SA, that's just going to be the 2 bases of the prism, which we know, the area of those 2, plus the longer net, right? This is going to be the net. We'll figure out the net in a bit, but let's keep in mind that we already know what the surface area is for these faces of the prism, right? It goes back to here. I found in red that it's 5940. So these are 5940. 5940 centimeters squared. So 5940 centimeters squared. Looking at the net, right? If I was to take this figure over here, let's say I stretch it out more. Okay, let's lay it out as a long rectangle. What do you think values would be the width of it, that bottom part? Now, if you guess 93, 40, and 74, you are correct, right? That, again, if I pulled this down and laid it out, you'll see that your base or your width of that net is going to be those numbers added together. So I'm going to put those together. Well, okay, we got 93 plus 40 plus 74, which gives me 93 plus 87, 180, right? And then I need that length part. And you got to think about, if I'm stretching it out, what's going to be that upwards part? Well, that should be 70. So this is a 180 by 70 net. So we're going to times those together. And 180 times 70 should give me 12,600 centimeters squared. Now I just got to add my surface area, add them all together. So now I have 5,940 plus 5,940 plus 12,600. Use my calculadora. I get a total of something wrong. Oh no, what did I do this time? Let's double check. So we said the height is 70. I think I added these wrong. Yep, I did it again. That's okay. So I'm going back to my width. I added 47 instead of 74. Silly, silly Mr. Singh. So let's do 93 plus 40 plus 74. That gets me 207. This is going to be the right answer. So instead of this, I got that wrong. It's 207 times 70, which is 14,490. 14,490. All right. We add that up. What's my answer? I should get 540. Now I got the right answer of 26,370 centimeters squared. Okay, so that is my answer, students. We found the surface area by taking the base, the top and bottom of the base of this wheelbarrow, and then found the net of it, added the surface, the area of all of those, and we got surface area, right? So wrapping it up, when is it necessary to consider surface area in solving a problem? Well, to consider it is when you are covering an object, when you want to know how much is exposed to the environment. Exposed meaning that what's being used, right? In this case, if we took cement and just poured it in, but then we left a layer of cement, we're saying, oh, well, how much cement is still covering that wheelbarrow? That's when we use surface area, all right? When is it necessary to consider volume in solving a problem? When you're filling up an object, remember all volume is how much space is being filled up inside some kind of container, some kind of 3D object, and anything similar to that, right? So if I was to get this, the volume is going to be inside this water bottle, right? Outside of it's my surface area, which leads to the next question is, if I cut an object in half, so I cut it in half, how does it affect the volume? Remember, this is the same by cutting the object in half. Well, what's going to happen to the water? The water is going to overflow, so you need a longer water bottle, right? Or the volume is going to stay the same because the water wants to get out now because I cut this in half, right? I took this and chopped it in half. And the surface area will also increase because this water bottle needs to be longer to hold the volume, right? And that's it for the lesson, really. So today you were able to decide whether to use the surface area, volume, and understand those concepts. Go ahead and answer the question below. That's kind of the cool down question about surface area differences. Be positive, like that says. Please keep working hard. We're almost done. We got one more week. And let me know if you have any questions. I'm here for you. I've been here for you, right? But please make it a great day, and we'll see you next time. Bye.